Right, carrying on with our features of graph series, let's have a look at a power graph. So this is a standard power graph. I've got all these numbers I can change in here, but at the moment my power graph is y equals 2x, and everything else is just not even part of the graph. So 2x, 2 to the power of x. So for example, I can have this point here. Let's zoom in a little bit and we'll see if we can get the number 1. So 1 to the x to the power 2 to the power of 1 is 2. 2 to the power of 2 is 4. 3 to the power of 2 is 2 to the power of 3, get it right, Mr. Bryant, is 8. If I can get the point nicely, there it was. 3 to the power of 2 is 8. 2 to the power of 3, get it right. 2 to the power of 4, I'm going to have to go up the graph a little bit, and I find this point here at 16. If you've ever played the game 2048, then those are my simple numbers: 2, 4, 8, 16, 32. Every time I go from one to the next, I'm timesing by 2. It's all about to the power of 2. Okay, so let's do the simple transformations first. I can slide my graph up and down the y-axis. The shape stays exactly the same, so the features are, it's a power graph, it's a power of 2 to the power graph, and all I'm doing now is, the only real point I can worry about is where it crosses. So here it's going to cross at 5. It's going to get really, really close to this 4 line, but it's never going to touch it. So let's go way out here and see if we can find the function. So it's getting really, really close to that line 4, so close that we can't even tell that it is not there, but it does not touch it. The decimal places get so many. Let's try another one here. There we go, 4.001. So our graph is limited by how many decimal places we can go. So it gets really close to that line 4, even though it looks like it touches and our decimals tell us it touches, it doesn't touch. That's one of the features of a power graph. It will get really close to a line on the left, but it doesn't touch. So if I wanted to turn that around, if I needed it to get really close to a line on the right and not touch, I would change this to negative. So let's change this to -2. And there it is. Where's my graph gone? It's still there. It's just disappeared beyond view. Okay. -2 to the power of... Okay, something goes on there. Right, negatives don't work. And boom, gone once we're negative. Okay, so a feature of this graph is it only exists when the powers are positive. Okay, sometimes I need to remember some of these things for myself. So there we go, there it is. Going the other way, what's going to be the opposite of that? It's going to be 0.5, I believe. 1/2. Not negative this time around. There it is. Okay, so I'm going to bring it back down to 0 just to make sure I'm right. So -1, -0.5 to the power of -1 is 2. Okay, if I can get the exact point, there it is. -0.5 to the power of -2 is 4. Okay, so here is the opposite of my 2 power graph. It's my 0.5 power graph. But what I really wanted you to see is that it gets really close to the 0 line, but never touches it. Getting really, really close. And the thing that's going to stop us seeing that is that our decimals run out. Okay, it says it's touching it there, but it's not. Okay, it's because our decimals have run out there. Our decimals aren't good enough on this particular graph. Right, so there is a power graph. What does it look like? It's a bit of a curve, maybe like a spaceship taking off into space, or an airplane that for some reason just keeps going straight up. So let's go back to our nice number 2 graph. Boom. And if we were to zoom out, it almost looks like it's going straight up, even though it's really not. It's kind of always on a little bit of a slope, but it gets steeper and steeper. But the left-hand side gets really close to this line 0, but doesn't touch it. Okay, so those are some of the features of a power graph.